easy high. Please fortify this strength of mine. My weakness comes and goes. My weakness comes and goes. I give in to the lesser fight. My body aches to be satisfied. My weakness comes and goes. My weakness comes and goes. I'm reaching out for the easy high. Please fortify this strength of mine. My weakness comes and goes. My weakness comes and goes. Echoes in my soul. My weakness comes and goes. It goes, it goes. My weakness echoes in my soul. Oh, it echoes in my soul. My weakness comes and goes. It goes, it goes. so fast, all tied up like a captive. I'm on to you. Used to pit in my mind like standing on rainbows, playing it cool. I haven't felt this in ages, and I've no patience. So won't you please stay a bit longer? You're making me stronger, making me stronger. Stay a bit longer. You're making me stronger, making me stronger. Ain't no luck finding real love. Got nowhere to look. Time moves fast, and I roll now. Yeah, I run to you. Used to pit in my mind like standing on rainbows, playing it cool. I haven't felt this in ages, and I've no patience. So won't you please stay a bit longer? You're making me stronger, making me stronger. Stay a bit longer. You're making me stronger, making me stronger. What can I do to make you stay a little longer? You're making me stronger, making me stronger. Stay a little longer. You're making me stronger, making me stronger. I'm alone, I'm a broken home. I gave you all the bricks that I own and know. I'm letting go, I'm breaking these walls down, breaking these walls down. If you want adventure, then fly to home. But if you wanna travel, then go alone. Yeah, what's the point in us if I never know? Yeah, if you're gonna leave, I'ma let you go. Away. I'm tired of the pain. Go away. I'm tired with I fell where my demons dwell. My own little nightmare, I call it hell. Oh well, it's time to get back up, climbing and climbing. I'm done with this ride, is what I tell myself, so I could feel something else. Yeah, I guess I had my bad days, but it doesn't mean I lost my style. Darling, where were you when my heart was on the ground? I thought time would prove that you would stick around. I guess time stands still, a king without his crown. Now I'm breaking, you're faking, girl. You never made a sound. Away. I'm tired of the pain.
Hello, everyone.
Hello, how is that?
สวัสดีค่ะ Can you hear me?
Yeah,
Yes. Welcome everyone from YouTube platform and Facebook Live to our meetup today.
welcome everyone to GraphQL Meetup 10 GraphQL 10.0 Meetup. Thailand for the second day of the live. So for today, we have a lot of interesting talk that we are going to have. But first, like yesterday, we are going to have like some quiz first to warm up before we get into the session. So how is the quiz today, PIs?
The quiz today will have like 10 quiz. So if everyone is ready, we will start it and we will have an answer after. Do you want to start it now, Phanom?
Yeah, sure. I think everyone is like really excited for the quiz of today. It's like, yeah, I think we are already. So just like yesterday, you can use the what is it called, the URL on the screen and the password and the passcode to join the quiz. So I think I'm quite excited for today's question. What is it going to be about? But I think it's going to be like GraphQL like yesterday, but a bit harder because we learned a lot about GraphQL yesterday.
Yeah.
So
that sounds interesting.
yeah,
So
first one.
if you are here already, please join us on our game before we start the session.
So PIs. So how long should we wait before we start the quiz? Like it's 5 minutes, okay? Or we can wait longer than that.
Or maybe we will start around 7 p.m.
At 7, yeah, 7 p.m. is fine. But so if you guys are interested in our quiz, you can join to like challenge yourself or like something like that. But yeah, I think let's wait for like I think let's wait for like a bit more, couple of minutes, like 2 or 3 minutes should be fine, I guess.
Yeah.
Because there's
7:15. Yeah, like if we have some player in our game in about 20, maybe.
Yeah, I hope so. That
yeah.
John Doe up here. Yeah, I
say
think
hi to John Doe, Ye, and Jonathan, right? And Kun Michelle Omato and John Don.
Jordan.
And Sajak. Okay, we have 6 players now.
I think let's wait for more 1 minute before we start quiz. Yeah, that should be fine.
Okay, Kunam, while we waiting, can you a little bit talking about what will going on for the next session? What is it about, or who is our speaker, please?
Yeah, sure. For the next session, we are going to have a talk about serverless and the schema stitching. So on the yesterday on the Kunbim topic that we talk about the Apollo Federation. So the schema stitching is like an alternative approach to solve almost like the common problem that have with GraphQL, but it's like an alternative approach to federation. So stitching is like you have a lot of GraphQL queries, right? And when you are using the data structure is like quite complex because you have to map the query all together because the type model is like different on each other. But with the schema stitching, you can like merge and reform the schema on fly on GraphQL, so the front end guy doesn't have to like ask you that which one have this relation together, or how can I map the relation of the data together. Yep, so that's going to be the first talk that we are going to have after this quiz. But since everyone have been like waiting for so long, I think we can start the quiz now. Yep.
Yeah, it's 7 paper. Let's go, okay.
Yeah, so in 3,
Now,
2,
okay.
1, and start. Yep. So like yesterday, we have like the scoreboard of the player. So we're going to. Oh wow! So the first one is like really fast. So it seems like Kunbeam from yesterday also joined today to the question, and yep.
Yeah, John Doe already number 1. Oh, Kun Ye already number 1 now with 1,000 points.
Like a lot of people starting to like going really fast. So I think there's, but I think everyone have to be like to be careful, because if you are like misreading the question, you're gonna have like have a lesser point, even though you have like the fastest speed answering the question. So I hope everyone is like be careful about the question. Yep.
Yeah.
So there's John Doe with the fourth stick of the question. So it seems like he is doing really good at this point. Oh wow. Oh wow, it seems like today's question is like a bit tricky. So let's see how is everyone doing. So for now, there's like 60% accuracy for like answering the question. So I think the question might be like a bit tricky, because when you're trying to like get fast, you're like bound to like answering the wrong question, or maybe the question today is like really tricky. But we can see about that. We are going to have like the answer session after all, so you don't have to worry about the question. Yep.
Yeah, but so far so good. Looks like everyone like 65% accurate.
Yeah, everyone is like so fast at this point.
Yeah, looks like we have got 2 people almost done.
Yeah, and Kunbeam has done, and it seems like everyone is almost done with the question. It seems like the last question is like quite tricky, because it seems like everyone is taking some time answering it. Yeah, so yeah. Oh wow.
Let's see.
Let's see.
We will have a surprise winner or not.
Oh wow! Someone has just joined as a 9 player. Wow, that's like unexpected. But let's see how he does. So I think we are going to like wait a bit, like 2 more minutes before like showing the answer to the question, since it's like the game has like time and speed related together. So yeah, let's wait for more minutes before we show the question.
For the player 9, we'll wait for you. And create to didn't finish.
So since we are all waiting, we can like have some talk about some of the second session. Can we?
Yeah.
Yeah. Okay. So for the second session is about the front end, back end, databases, and GraphQL. So it seems like in this talk is from This talk is the speaker of talk is from Hasula. So Hasula is like uh, a very interesting platform for like creating or talk to your database using the GraphQL without any help. You can just like up into the Hasula, and then the Hasula will generate the GraphQL schema that you can like query directly from the database and mutate them directly without any middle server help. So that's like really interesting that the speaker from Hasula is joining us today. Yep, I'm like really excited for that.
Yeah, thanks. And that
I
sounds
think
exciting for me too.
Yeah, I think it's about time that we really like let's see what the question is about. So okay, the first one is like how do you know about this meetup? So this question doesn't have like a wrong answer. So it's like surveying how you like know about uh our meetup. So we can like for the next meetup we can like have some help with where we can like promote or something like that. So yeah, so the first one doesn't have any problem. Okay, for the second one, who will be the speaker today? Oh wow, this is like a really tricky question because it's like having a multiple choice, and like it's like you have to like memorize it or you have to find it. So this is like quite tricky. But for the speaker today, we have let's Kun Vi the Kun Vishwa Meta from the Hasula that I just mentioned earlier for today. So she's a speaker from Hasula that I'm really excited and looking forward to like for the talk. Okay, for the third question, let's see which one is the topic for today.
Yes.
So the topic for today is like as I mentioned, there's the front-end frameworks, back-end databases, and GraphQL is the answer for the question. Yep. It's like this is also tricky because you have to like memorize the talk name.
Yeah.
Okay, so this one talk about when was GraphQL is created. So this question is like almost a bit tricky too because like let's say if I wrote, oh wow, so also it seems like everyone finished the the question. So the first place was Kunbeam. Oh, let's see. Oh wow, like
Congratulations for Kunbeam for the first one, and the second is Kun Michael or Michelle, and the third one is John Doe, right? So Kunbeam missed the question.
This is the last question. Oh,
the last question. Yeah,
okay,
and the second and the third one is not too far from each other.
Oh yeah, we have like the answer sheet like for the answer. So okay, let's continue on the fourth question. So the fourth question is when was GraphQL is created? So to be honest, I doesn't remember this also. So if I were to have like answers to some question like this, I wouldn't be able to answer, to be honest. So the answer is from the 20 and 12 was I think it was like internal engineering and developing internally. So yeah.
And Kunal, I think right now Kun are already ready for us, but do you still want to talking about quiz first, and then we will let Kun Fa join us, or we will just skip this part?
I think we are going to have like some spare time later, but so I think we should like stick to the talk first because it's like so the guest can be I think we should stick to the talk first. Yeah. Okay.
Yeah. So then that sounds good. Then please welcome Kun Fa and clap your hand for welcome Kun Fa. Hi, hello. How are you?
Hello. It seems like you have the static sound in your microphone.
What about this one? Should be fine, right?
Yeah,
Okay, good.
this is
Great.
better.
Yeah.
We can
Yeah.
hear
Sorry.
you
Sorry.
clearly now. It's okay. Are you ready for the session?
Um, I would say yes. Ready. Okay.
Yeah, we are here and I will be here whenever you want. We will stay together and your time will finish around 7:50. Please still be here. Please call us every time if you want, and I will read some comments that want to if someone want to talk or have any question.
Okay. Yeah.
So if you're ready, you can start it now.
Okay. Yeah. I will put play button, which is I can't see anyone now. Yeah. Good evening from Thailand again, everyone. Yeah. My name is Far. I am backend engineer at Brico. Yeah. This is actually my first talk, and super excited to be here for giving a first talk for this GraphQL meetup. And yeah, just so you know that this one is actually my first time speaking, so it might not be a perfect one, but I will try my best to make it like smooth as much as I can. Okay. Um, yeah. What we're gonna talk today is about the schema stitching is the main topic, and we also have like serverless architecture, which is we're gonna show a use case when what's the benefit when we use serverless architecture with the schemas with the distributed GraphQL that using schema stitching. Okay, a little bit about myself. I am backend engineer at Bico. Yeah, I'm mostly focused on serverless architecture. Yeah, and design and maintain GraphQL API. This is mostly my responsibility here. Okay, and then a little bit about this talk. We're gonna go through like why we need distributed GraphQL. Yeah, and yeah, distributed GraphQL that come from that's on top of microservice, right? And why we need GraphQL to be distributed, how benefits of that, right? And then the second one we will go through like why schema stitching. Yeah, this one is like you already heard, you already listened to the talk yesterday about upload federation, but this one is just the alternative one about schema stitching, which is the way to to aggregate, to merge the multiple subschema into one in the gateway. Yeah, it's the same thing. So the next one will be I would say that this one gonna be a small the serverless architecture using with schema stitching that we deploy the whole system in serverless with GraphQL server for each lambda, I can say. Yeah. Okay. Let's go to our first topic. Yeah. Why we need distributed GraphQL? Yep. I can say that the GraphQL, if you work with monolith system, GraphQL server, it's gonna be simple, right? You have one simple schema, so you can fetch data from that server, yeah, without tricky. It just one schema, nothing hard, right? But the thing is, when you work with the microservice, for example, you have multiple subservice behind the gateway, like you have 20 subservice behind the gateway. How with the GraphQL schema, how you gonna maintain or handle the connection between gateway to the subschema? Yeah, and how you gonna unify and transform the schema before sending back to the client? Yeah. Okay. I guess we can start with super simple e-commerce platform, e-commerce system, which is we have product service, order service, and user service. Yeah. Um, okay. What's the GraphQL distributed GraphQL will be, right? It's gonna be like this. Of course, we need to have a gateway to to you still need to have gateway to combine multiple schema, right? So the thing is, how you're gonna implement merging configuration. I mean, how you're gonna implement the way you merge multiple schema, right? You can do like many ways to do that. You can do yourself, like implement the resolver to get the data from order service, and then you just need more data from product service. You just manually create the logic to fetch all the data behind the sub-service, behind the gateway. Yeah. For example, you need the order data and the product data at the same time. Like for example, you need to get the product data inside the order. So you need to make a query, right? So the query will go through the gateway. So somehow gateway should know which service is gonna fetch the data. So that means, yeah, the distributed GraphQL is something like you merge all the schema in the gateway, so the gateway will know which one you're gonna which service you're gonna get that data. Okay, just like that. Okay, yeah, this is the example of GraphQL schema of the distributed GraphQL. This is, you have one gateway and multiple sub-service. So before we go through more about the distributed GraphQL, we need to know more about the microservice, right? If we don't have microservice, we don't have distributed GraphQL. So yeah, before we go through before we go through the distributed service, GraphQL service, right? We need to know the microservice. And okay, sorry. Okay, the first thing first, there is a problem with the monolith system, right? Before when you implement when you implement the application, yeah, it's gonna start with monolith first, right? And your system growing bigger slowly over time. So that means you have a lot of complex logic in one server, right? So all complex business logic is in the same server. So every request will go through the same server. So what's the issue of this kind of architecture? Yeah, the first thing is you have like single response. You have like single point of failure. Yeah, because this is too much responsibility for one server. If there's some small mistake like X of undefined, yeah, if you are familiar with, and of that one will might bring the whole system go down, which is the bad thing about monolith system with a complex with a complex logic inside. And also we have the issue with horizontal scaling, which is the horizontal scaling in monolith system is a matter of duplicate the same big system. You just need to put more instance to handle more load, right? So that means you just make a whole system deploy again and again, which is also not good, right? But with the microservice system, yeah, as you can see, it's quite obvious that we can split it down into multiple services. We can split it down into multiple services from something like business capability. Like we have product management service, we have order management service, and user management service, right? So there are a lot more advantage for the complex system, for the complex system to be microservice. Yeah, the first thing is we have the advantage of individual scalable, right? Because when you see that there are some service that have a lot of traffic there, you might need to just scale on specific service. So you just put more instance to that service. No need to concern about the others. Like you have order service, a lot of traffic go through order service. You just focus there. right? But in monolith system, you need to duplicate a big system more and more, which is not good, right? And yeah, and also the next thing is you can do like independently deployable, which is um, you can choose when you're going to deploy, and you can also choose which service you're going to deploy, right? Compared to the monolith, you just need to, if you have some small change, you need to redeploy the whole system again. And after you redeploy, there might be some situation that you also need to test the whole system, right? Because it is in the same server. You have to, you need to have a good test case to make sure that some small change might not bring the whole system, the other part of the system go down. But with the microservice, you just split it into multiple instance, which is can be independent. Yeah. And the next thing is it's loosely coupled, which is if you have, the two developer working on order service and product service, they don't need to think too much about the don't think too much about the effect when they have some change. They just separately working on their own, and yeah, just deploy on their own. No need to think too much. And then we have fault tolerant system in the microservice. It is in the monolith system, you have single responsibility, right? But I mean single point of failure, right? But at this time, you just spread it into multiple point of failure. So one point down, it's not bring the whole system go down. It just that one go down, right? So yeah, that is the big advantage of the microservice system. So yeah, that's why we need a microservice. So what's happened if we have microservice with the GraphQL, right? So we're gonna have like distributed GraphQL, which is multiple GraphQL server behind the gateway. Yeah. So okay. And then we're gonna go to the next topic, which is why we need schema stitching, right? As you might already listen to the yesterday speak about the upload federation, schema stitching is using the same way. I mean, it solves the same purpose, which is you need to unify the schema into one in the gateway. But the thing is, which one is better? Why you need the upload federation, or you need schema stitching? The thing is, the schema stitching is I can say that it's a lot more flexible in terms of how to say it's you can use any server, like you can use GraphQL Helix, you can use the GraphQL server one, or even upload server you can also use to do like schema stitching. But with upload federation, and it has to be like built on top of upload server, right? But yeah, and also for the upload federation, you need to be specialist for upload for the upload ecosystem, right? But with schema stitching, you just need to know the logic, how to combine. It's bare metal. You have ability to do some configuration to merge data in the gateway. Yeah. So that's why the big point of the schema stitching. Okay. Let's get a bit more about schema stitching. I'm gonna show you a demo, quick one. Yeah. As you can see here, yeah, we have user service run in the different server, and yeah, as you can see, and in the middle we have the product service also run in the different server and other service. Of course, we need to have the gateway to combine them together, right? So this is example that I will show you how the traffic goes when we run. Like the first query, it's gonna trigger all the three services, right? Because you get the created by, which is belong to the user, and you get the product, which is to belong to product. service. But yeah, so it's gonna get to all the service, right? Like this, for example. So but if you try to put some comment for the created by, that means you no need to fetch the data from the user service, right? So as you can see, the user service will be blank here, right? But yeah, at the same time, if you remove the product here and you run, yeah, you also just the query, the traffic, the request will only go to the order service, just like that. So yeah, this is the how schema stitching can be. Yeah, but what's going on behind the scene? So we need before we go through how schema stitching work, we need to yeah, let's get back into our e-commerce system, right? So yeah, for now we have three different services running separately. We have GraphQL service, user, order, and product. And then the thing is, at the schema can get the SDL, right? The schema can fetch the schema. I mean, the gateway can fetch the schema from the user and from the order and from the product and bind and merge it together at the gateway. Yeah. So this is the concept of one unified data schema, right? One unified data graph. So that is how distributed GraphQL could be, right? Okay. Yeah, this is the example that I showed earlier with the live demo here. Okay, and then let's go to the real implementation of schema stitching. Why we, yeah, how it's worked behind all of this. The first thing first, you need to know the concept of type merging. Yeah, the type merging can, how to say, the type merging can merge the partial schema from each how to say, it can merge partial schema from different, I mean the same schema, the same type from different subservice in any subschema, and then you can get all that partial schema merged together into one type. For example, yeah, we have like order service and product service here, and we have, like, as you can see in the order type at the order service, we have amount, field, right? And in the product service, we also have the same order type, but it's also hold the product field. Yeah. So this way you can merge them together into at the gateway. So in the front end point of view, when you check, when you do some introspect to the gateway, you're gonna see the whole type merged together like this. So when you do a request, yeah, the schema stitching will know. The schema stitching will how to say, the gateway will know to get which data, where the data we the gateway need to get from. Yeah. So the schema stitching is the combination of three components, right? The first thing we need to have is executor. We need to have executor to make a gateway to the gateway to have ability to get to do some requests, to do the GraphQL request to the subservice, which means yeah, this executor is just a function, like HTTP client, can be HTTP client that can fetch the GraphQL data. So the implementation, if you're familiar with Node.js environment, there will be like Node Fetch or Axios. They can be either or alternative like Garten, or you can use any library to be a remote executor. So yeah, when you have the configuration in the schema in the gateway, you need to define the executor, which is like just define the basic HTTP client, like you need to do some requests, right? Like for example, here you have order schema, and and product. You have the order executor, product executor, and user executor here. So you can define the part that belong to each subservice. Okay, and after you have the remote executor, what you need next is you need to fetch the schema STL, right? Because gateway need to know the whole schema from each subservice, so they can bind together, and also they know how to which type they need to do some like dependency. They need to fetch in dependency order. Like you have the order query, and inside you have product. You just and when you make a query at the gateway will know that they need to get the order data first, and then in the order data they will have the order ID. So they will get that order ID to fetch the order. They will have the product ID, and gateway need to use that product ID to fetch the product data in the product service. So it's gonna be two network call before aggregating at the gateway and send back to the client. Yeah. And the next component that we need to have type merging configuration. Yeah, the type merging configuration is basically how you're gonna merge type. To be more clear, it's just you just need to tell the schema. You just need to tell the gateway for which query from like for example from product service you need to use for getting the product data, like this. Yeah, you need to use like field name here. There is product query, so it must provide the product query at the product service to for the gateway to have ability to fetch the product data. So this is all the components of schema stitching. So if you have all of this, you can do like everything about schema stitching. So there are some couple of techniques about like you can do you can do like batch array query. You can combine multiple you can combine the same type together and do batch at the same time. Yeah, but I'm not gonna go through all of it. Yeah. But there are some technique that we can optimize the network call in the configuration. Yeah, but the thing is, what's the issue with type merging configuration here? The type merging configuration here, if you think, for example, if you have like 20 services, 20 different services running on this, running behind the gateway, so the gateway need to know how they're gonna merge the data, right? How they're gonna merge so that means you need to define configuration for all. So you need to define the configuration for the gateway to make gateway nodes for every 20 service, right? So that means the gateway will be, you need to also to maintain the gateway. Gateway will be bigger and bigger if you have more and more service, or you're gonna have like more and more type that need to do some merging. Yeah. So yeah, that means the relation config all in the gateway, which is make a gateway bigger. But they also have the same approach that can be finished, can be done like the upload federation, which is we can use the directive SDL, right? So the directive SDL is like it take the same approach. So you don't need to define all the configuration in the gateway, but you just add all these custom directive at the sub schema. So just like this, if you add all these directive to the sub schema, it's basically the same thing to what we config in the gateway, but we just use custom directive to build that configuration in runtime. That means gateway So gateway no need to be redeploy when you have some small schema change in the gateway in the subservice. But gateway can load. You can do hot reload all the schema from each subservice. So the gateway will be like super simple container there. So it just stay there to fetch all the configuration. So you don't need to add more and more configuration to the gateway. That's the thing. It takes the same approach like upload federation. So yeah, that's all about schema stitching that I can say. And the next thing, we're gonna have 7 minutes here. Yeah, the next thing will be, what if we have microservice, GraphQL, and serverless architecture together? Like, okay, before we go further, we need to have a bit more about serverless architecture, right? Okay, serverless architecture, it doesn't mean like we don't have a server, right? But it's mean like we don't need to responsible for managing provision or do some provision to their server. Yeah, it's just the way to build to run the application without having any concern to managing infrastructure. You just put it all responsibility to manage the system by cloud provider, just like that. So you no longer to care about hardware OS. You need to patch something like that. So developer can only focus for the code and business logic. Okay, sorry. Like I said, the developer can focus just for the business logic, just like that. Yeah, so that's been but there are multiple kind of serverless architecture, right? It shouldn't have to be always function as a service. It can be like many other kind, right? We also have like backend as a service, like database system. So you don't need to worry about you don't need to worry much about the when you work with like for example, you have DynamoDB, right? You just go to the table, you just create a table, right? And you don't care much about how things work behind, right? You let all things done and managed by cloud provider, just like that. So you abstracted away from underlying server. Yeah. And and they also have like function as a service, for example, the Lambda function from AWS. So you can run the code at the Lambda function and that running by cloud provider, right? So the Lambda function can you can put a small business, a small logic, a block of logic there. So you can just run the function as much as you want, and there's no idle time. So you just pay for per invocation. Yeah, something like that. So there are some couple benefit of using Lambda function, which is you no need to host configuration. You just pay per invocation. Yeah, and it can also be scaled on demand, and there's no idle time because when Lambda function running for the certain of time and there is no more request, it just sleep, it just achieve itself and shut it down. So the next time when you need to invoke the function, it's gonna wake up again. Yeah, but it's come with some but you need to pay for the time that you need to wake up, right? It has some kind of cold start there. Okay. What's happened if we work with the how to say Lambda function as a microservice? You can treat like one Lambda function as the container implementation. Like you can have like upload server run on the one Lambda function, which is responsible for order service. So that's mean that's mean you will have ability that you will have the advantage of of serverless architecture. Like I said before, we have we just pay per invocation. It's super cheap this way. Yeah, so you also can host the order and product the product service and user service in the other Lambda function that also run the GraphQL server. Yeah, that way it's make much more how to say it's like you can have the ability to do one unified data graph, and at the same time you also have like the performance at scale. Yeah, so you no need to worry much about provisioning the Kubernetes cluster. You have like a lot of multiple instance that you may like have over provisioning or under provisioning if you use like the Kubernetes cluster, something like that. But it's not happen in the serverless architecture. But they also have some issue with that. Like, yeah, of course they have cold start. The cold start issue is the thing that this is the only thing that serverless that is the serverless downside. But what is cold start? It's like when you run the server, when you invoke the function, right? So the function in a certain of time, the function if function is inactive, it's gonna sleep, right? So the thing is, it's gonna achieve itself and it's gonna shut down. So next time you invoke the function again, it's gonna start with fetching the data from the data storage like S3, and then need to extract the zip file into the source code, and then it's run. So that take time. That process take time. So that's why we have a cold start issue for the serverless architect for the Lambda function. But you can also fix that. You can also prevent, how to say, you can also make a cold start faster by just make a packet size smaller as much as you can. So the cold start will be faster. Or you can have like concurrency. How to say concurrency? You also can have serverless concurrency provisioning, right? So it can run. It can config. You can pay like let's make this Lambda to run for the certain number of concurrency, something like that. And also have the issue with the testing obstacle, which is when you develop in the local and in the production system, it's not going to be the same, right? It's quite super hard to test for both environment, and they also have like execution duration limit. So this one we need to be aware of. Yeah, I think that's it from this talk. Yeah, thank you.
Thank you. Yay.
Hey, thank you. That's like a very nice talk and very clear. Yeah.
Yeah. Sound
So
interesting. And anyone
let's
have
see
some
the question from the viewer.
That was so good, Captain Pa. How are you doing right now?
Yeah, I'm the same, super nervous to give a first talk.
Yeah, it's so good for first talk.
Yeah,
Oh,
you
thank
did
you.
really nice
Yeah.
job.
Yeah.
I think I just lost a lot of information here. They're gonna be a lot more here. Yep. But it's just 30 minutes. Yeah, can say everything about GraphQL, serverless, and distributed GraphQL at the same time. I'm
Yeah,
just trying
so
to
you
make it
can
compact.
yeah.
Sorry about
So you can
the lack of information.
yes. It's fine. If you have more information, you can share your contact or your information that our attendee can go and follow you on there. Please comment it, or you can tell them right now.
Okay. Yeah. Okay. Is there gonna be Q&A session, right?
Yeah.
Yeah, but looks like
Any question
you
there?
have any question here, only the compliment like great job and can't believe this is the first talk. It's so smooth and great job. And yeah, one question now from Kun Pumperin, can we also use
Just like Kubernetes instead of
yes,
serverless.
Yeah. There's nothing to do with serverless itself. If you run distributed GraphQL, yeah, you also can run the GraphQL distributed GraphQL in Kubernetes cluster. Yeah, it's kind of the same thing, but yeah, the serverless is alternative one. They also have some useful thing like I said, we have it's super cheap. You just pay for invocation. Yeah, but you need to remind that you just need to make a packet size as small as you can. So it's gonna be the code start and that take very long.
Yeah.
okay, thank you for your answer. Anyone
So
have any questions?
yeah. So seems like if there's no one have any question, I think
Yes,
we
because it's so good and so clearly from Kun Far. And we have to say thank you so much. And will you go to join our Get the Towel at 9 p.m. or not?
Yeah, sure.
Okay, then
yeah.
if anyone have any questions, please go follow him or go to Get the Towel. We will show the QR code, but we will open the Get the Towel at 9 p.m. So let's see Kun Far and us there at 9 p.m. right? And thank you so much, Kun Far.
Thank you. See you.
Yeah. See ya.
See you.
Okay. For the first talk, let's recap for the first talk. So, the talk that have finished just talking about the serverless and the schema stitching in on the Upload GraphQL. So, to recap, the schema stitching help you to create a distributed graph. So you can query the data from multiple microservices or in one place. The configuration is in the services, so the gateway stay lightweight. Combined with our serverless architecture, you don't need to worry about maintaining these services and spend more time on writing code. Yeah. So that's the recap for the first talk. And do you have do we have any are
We
we
have the
going to
recap
like
in
have
Thai version too.
oh yeah for the
Yeah.
Thai version
Yeah.
let's
โอเคสำหรับ Schema Stitching นะคะช่วยให้เราสร้าง Distribute Graph นะคะได้สามารถทำให้เรานะคะรวบรวมข้อมูลมาจากหลายๆ Service เพื่อให้ดึงข้อมูลได้จากที่เดียวนะคะโดยที่ไม่ต้องตั้งค่า Gateway เยอะเกินไปนะคะแล้วก็เมื่อใช้ร่วมกับตัว Service-less Architecture นะคะก็จะทำให้เราไม่ต้องเสียเวลากับการดูแล Service ก็จะทำให้มีเวลาไป Coding มากขึ้นนั่นเองค่ะสำหรับอันนี้ก็คือ recap in Thai version for the first talk ค่ะ and we going to let everyone break and we will come back again at 7:55
yeah
p.m.
so we are going to see in 5 minutes so
yeah in 5 minutes we will be back with the second speaker and we will talk a bit what is it about and who is the speaker. See you ค่ะ
yeah see ya
Loving me is loving danger. Your heart is bound to break. I walk alone in the night, neath the pale moon. Loving's for the fools. Baby, beware of my body. I'm alone, I'm alone, I'm a lone wolf. I'm a lone wolf. I'm a lone wolf. I'm a lone wolf. I'm a, I'm a lone wolf. I'm a lone wolf. I'm a.
Welcome back.
Yeah.
Yeah, so what is about this talk, Garten?
So this talk is the talk about the front end framework, back end databases, and GraphQL. So uh, for the brief, we are going to have a talk from the speaker from Hasula. So this talk is going to talk about what is GraphQL and what are the technical consideration when you are evaluating your API strategy, and how do the Hasula approach the major refactor. So yeah, I think this topic is like for like every dev in almost every area that we can talk that we can like understand together. So I think this talk is going to be like really nice for everyone. Yep.
Yeah, so that sounds interesting, and I think speaker is already ready. So please welcome and clap your hands so loud for our speaker. Ka.
Hello.
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 Thank you so much for having me today. Super excited for the talk.
Thank you so much for joining us too. And how are you?
I'm good. How are you folks?
We are good. Thank you
Yeah,
for
I'm
asking.
doing good. Yeah.
Yeah. Okay. So we will let you have your session, and we will back again at 9:35. Okay. So
Mm-hmm.
please enjoy your time and have a good session. Ka. You.
Awesome. All right. I will share my screen. Just a sec. This is going to create that infinite loop of showing the screens. It's always weird to look at it. Anyways, without further ado, let me get started. Hello, everyone. I am super excited for my talk today. I've been taking a little bit of break from giving public talks and presentations because I've been working on some some really exciting content, and I'm super excited to be getting back to speaking at meetups and conferences again this year. And the good part is that we all can these events make it super accessible to join from the comfort of our homes. So I'm super excited to be doing this again in a while now. So before I tell you a bit about my talk, which is front-end frameworks, back-end databases, and GraphQL, let me tell you a bit about myself. So again, hey everyone, my name is Vishwa Mehta, Vish for short, and I work as a developer relations associate at Hasura. So I work on a lot of community stuff, and I get to talk to a bunch of developers at every event that I go to. So yeah, and I get to work on a lot of developer facing content. And when I'm not doing that, I'm usually tinkering with GraphQL and React applications in my own time, building something new, and trying out new technologies. I graduated a few years ago in 2019, actually, from university with a bachelor's degree in computer science. And that's also around the same time that I started delving more into GraphQL. So I'm also wearing my favorite shirt, which is from my first ever GraphQL conference, which is GraphQL Asia. And I saw it very fitting for this event, for this meetup, so I wore it. So yeah, I am a front-end developer turned technical writer, which means I'm also very passionate about technical documentation. And I do a bunch of React stuff. That is something that I'm really interested in. So yeah, you can say that I'm also a React developer because I started using React. I think in 2018, and for me that was the introduction to front end frameworks, and that's how I got more into front end. Now enter GraphQL. It's something that was developed in 2015 by Facebook, as a lot of us might know already. I got introduced to it first in 2018, somewhere around 2018. So I wanted to in this talk. I wanted to talk about my own GraphQL journey, how I got introduced to it first, what is something that I find fascinating, how is it providing value to me as a developer, specifically as a front-end developer. And so in this talk, I wanted to speak to all of you in a way that speaks to each one of us, whether we are a front-end developer, whether you're a back-end developer, or if you a full-stack developer. So yeah, let's get started. First off, I wanted to talk about a bit about GraphQL and how I got first introduced to it, what fascinated me. I think around 2018, a friend was playing around with GraphQL, and that's how I first heard about what GraphQL is. And it was being used for building mission critical apps faster. That's how Facebook came up with it, right? It just to help us create real time applications faster. Now, let's talk about the key bottleneck in the developer space while building web apps or mobile applications, which is the API access part of the application development process. And what that means is that when we talk about app development, there are a lot of various different types of data sources, various different places where our data comes from. So that is kind of a question of as a developer, as an application developer, how I can solve the problem of API access. And that is something that GraphQL is trying to solve by being a unified access layer for all of our data, whether it's stored in a database or microservices or serverless functions, or whether we're using a SaaS application where that data is coming from. It probably has an API that we're communicating it, our clients are communicating with, right? So GraphQL is trying to solve that problem of the data API access. And that is something that I'll talk about in more detail in the next slide. Moving on, when we talk about GraphQL, we usually compare it to REST, right? So before I got introduced to GraphQL, I was using REST APIs. And so it only makes sense to think about how GraphQL is improving this experience by being self-serving. And what I mean by being a self-serving API is if you look at REST, the kind of issue that came with development with REST APIs is that a lot of front-end developers had to depend on back-end developers, whether there was whenever there was a slight change that we needed to make to an API, right? Because it's a static API, it's static in nature. So every time we had to change something in the data, the front-end developers had to depend on the back-end developers to make those changes into the API. And that is something that GraphQL solves for by being self-serving and self-documenting. So it kind of makes that experience a whole lot better for front-end developers. And that's something that I found really interesting and really fascinating when I was starting with GraphQL. Next, I wanted to talk about a bit about how GraphQL is fit for different shapes of data. Um, let's talk about mobile apps and web apps in contrast. The kind of data that you consume on your mobile clients is not always the same as the shape of data that you consume on your web apps. Because on your mobile apps you might need less data, and on your web apps you might need more data. When you're using REST, what happens is that um, you, it's for every use case, it's always a same shape of data, and you can't really make different shapes of requests for every different platform. So for mobile data, what you end up doing, for mobile apps, what you end up doing when you're using REST APIs is that you're consuming the same amount of data on your mobile applications as you do with web applications. And this is something that is significantly better when you're using GraphQL APIs, because in GraphQL APIs, it can consume different shapes of data. So what that means is for different types of clients, you can define what kind of data the client is going to consume. So that's something that I found really interesting about GraphQL. And all in all, I think it's an improved user experience again because of the introspection aspect of it. Something that I was blown away by when I got introduced to GraphQL is the introspection bit, how it is self-documented, and you can, when you start playing around with the GraphQL API, everything is in front of you. You can introspect the entire data model and the schema. And because of the schema and the type system, this kind of a consistent schema and a type system, you're not just able to introspect it, but also you're also able to build really beautiful and really good UI experiences, maybe for documentation or for other, maybe you can build a client application, right? And that is something that's possible with GraphQL because of the consistency in the schema and the type system. And that's something that cannot really be achieved with REST APIs. I mean, it would be wrong to say that it cannot be achieved because you can use Swagger and Open API spec for your REST APIs and achieve the same kind of purpose. You can solve for that purpose, but the experience is going to be significantly different because it's not as consistent as GraphQL. So that's something that I found interesting when I started with GraphQL, and those are the kind of problems that GraphQL was solving for me as a front-end developer. Now let's talk about why GraphQL, right? So if you look at application development, there are various types of consumers, as I mentioned earlier: mobile applications, web applications, microservices, serverless functions, APIs for third-party developers. So that's your SaaS APIs. Now, in the whole scenario of application development, the consuming bit is not something that we're struggling at right now because computing is getting easier. If you look at microservices, you can write minimal code and isolate that into a function, deploy it, and get unlimited, infinite computing power, right? Computational power. And so infrastructure is not so much of a problem right now. What you can focus on currently is the business logic and the operational part of things. So let's move on. Let's talk about the data access part of the application development experience. And that is something that I feel takes a lot of time to build and iterate on. As I mentioned earlier, since there are a lot of various types of consumers, there are also various types of data sources that we're dealing with, right? So on the front end side of things, there are a bunch of clients that will be consuming your application data. And on the backend side of things, data is stored in various kinds of data sources. So the data access problem that we're talking about here, it becomes an issue because you're trying to deal with a lot of data that you want your clients to consume. So you want that kind of a middleware, that kind of a unified access layer that can provide data to your clients from your various databases or data sources. And these data sources can be internal services that can be distributed across various databases like MySQL, SQL Server. Um, you can also be using MongoDB or PostgreSQL, and that depends on maybe you have a different domain model for a different use case, or maybe you have several teams in your big organization, and every team is using it for a different purpose, authorization, or maybe your file system. So data is distributed among a lot of data sources, and now we're also bringing in SaaS APIs, which are external services, into consideration. You could be using Algolia for search, or maybe Stripe for payments and e-commerce. And that experience is also getting stronger. It's getting more robust, because databases are getting better at their services. We now have a lot of managed hosted solutions that we can use. So what I'm trying to say is that the core a problem that we're trying to solve here remains data access, and not the consumption or the producing side of things, right? Producers and consumers are getting better, and it only makes sense if the data access also gets better. And that is something that GraphQL can significantly help with. Now, before getting more into the Hasura side of the things, I would also like to touch upon the fact and address the elephant in the room. Whenever I talk about GraphQL at an event or a meetup or a conference, I almost always get the question of GraphQL versus REST. And the question makes sense. That's a valid question. The question is about whether or not it's a yes or no answer, whether or not it's a comparison, like how GraphQL compares to REST. Is it an either or an and? And what I think is it's not really a comparison. So no, not really a comparison, but it's an and sort of a thing. Like you can use GraphQL and REST and combine the benefits of both to sort of get a really good developer experience and user experience, and also leverage the existing tooling that comes with REST. So you don't really have to completely replace REST with GraphQL by writing writing your APIs from scratch completely into GraphQL. Because if you look at the REST space, a lot of it has been here, right? And it's not going anywhere because it's been here for a while. A lot of big companies are using REST APIs. They've built REST APIs that are here to stay because this is legacy code and you cannot replace it overnight. So does it make sense from the perspective of cost for a business to invest so much time and energy and resources into rewriting your REST applications into GraphQL from scratch? Or does it make sense to combine the power of GraphQL and REST to get that kind of powerful experience from existing tooling and the developer experience that GraphQL gives you? So what I feel is we should definitely look at solutions that can combine the power of both GraphQL APIs and REST APIs, so that we can start building that GraphQL data access layer over our existing REST APIs, and not spend time on completely rewriting everything. Now, there are also a couple of challenges of GraphQL that I wanted to talk about, and specifically for developers, starting with performance and caching. So, when you talk about performance, what happens is when you're querying some data, when you want some data from your server, let's say you have a users table and a product table. So for every user, you want a product that is associated with it. And that gives rise to the n+1 problem. And with the n+1 problem, what happens is for every user, you're also querying for the products. And that's how the n+1 problem makes the querying and your GraphQL queries slower, right? So that is something that's the performance issue. And also the caching issue. The problem with caching, and I know that caching, there are a lot of solutions right now that are handling caching really well. There are a lot of solutions coming up that and there's a lot of discussion in the community about GraphQL caching. Fundamentally, what happens is caching is still a struggle in the ecosystem, and we want to be looking at performance and caching in a way that's easier. Talking about operations, let's see why operations are harder. So this is another challenge with GraphQL when compared to REST APIs. It's because it has a single point of failure. And what I mean by single point of failure is if you've used REST APIs, you know that for every data that you want to access, there's a different REST endpoint, right? And that's not the case in GraphQL. GraphQL gives you one single endpoint for all kinds of data that you want to query from your data sources. And what that means is in REST, if there's a single endpoint that is down, all of the other endpoints are still functional. So some part of your application is still running while you can quickly work with various monitoring methods. You can quickly work on getting that failing endpoint up, right? And that's something that cannot be achieved in GraphQL very easily because there's a single point of failure, there's a single endpoint. So if that is down, if that API endpoint is down, your whole application is down. Similarly, with the aspect of rate limiting, if a client is spamming your API, what happens is you cannot easily limit the rates. You cannot easily control the kind of requests being made to your API, and that is also a challenge in GraphQL. And in business side of things, there's always a cost that is involved, and that's something that I mentioned earlier. The cost involved is the kind of time and resources we put into educating our developers in getting up to speed with GraphQL and how to, like, because there's a slight learning curve with GraphQL, right? And also since there will be a cost involved in terms of resources because writing GraphQL APIs, servers, building GraphQL servers is harder, right? Writing GraphQL resolvers is hard, and that's not something that can happen overnight in a big organization. So there's definitely a cost involved if you have a larger business, and if you have legacy code. So yeah, those were a couple of challenges that GraphQL, or at least using GraphQL, poses for now. Moving on to Hasura, which is the company and the product that I work for. We recently launched Hasura 2.0 this year. And what has changed is that we are supporting more databases, data sources now. And how that helps is GraphQL is now with like what we're trying to achieve with Hasura 2.0 is that GraphQL, we're making GraphQL and Hasura GraphQL engine that data API access layer for you now that pulls from all different data sources for you, right? And makes it possible for your clients to consume that data easily. And how that happens is Hasra acts as a compiler, and it solves for that n+1 problem when querying from a lot of different data sources. And what happens is that when you write a GraphQL query and you request data from the server, Hasra compiles it into SQL statements, and that's how it makes it easier and builds this unified access layer to be able to easily and fast access data from different data sources. Also, another feature that recently came out was REST APIs on top of GraphQL. And this is, so I know that I talked about building GraphQL APIs and building that GraphQL API layer over your REST APIs. But this is another feature that we provide, which is building REST APIs over your GraphQL API access layer. So if you have built your data access layer using GraphQL, you can still continue to use REST APIs over it by converting idiomatic REST endpoints from your GraphQL endpoint. And that is something that's a very specific use case that very specific developers and organizations use. But that's also a new feature that we provide. And generalized authorization. So authorization is really important because when you talk about data access and you're pulling in from a bunch of different data sources, you might have your user data in your database, your Postgres database, right? You might have the product details and all the cart and all the other information from Stripe, your payment information and everything in Stripe, and something else in maybe a microservice or something like that. And we want to be able to use a very strong permissioning system to be able to define how a certain user gets access to certain kind of data from a certain data source. And that's where generalized authorization, and that's how generalized authorization works. It's this generalized authorization layer and authorization engine that works across all of your data sources. And you can define permissions as to, you can define rules as to what your users can access from your API. And generalized joins is something that is coming soon. So just like generalized authorization, generalized joins is going to be it's going to let you join data from different data sources. So you probably, as I mentioned earlier, you probably have users data in a users table in Postgres, and you have some other maybe products table in Contentful remote schema, right? And you want to be able to join across those data sources, then generalized joins is going to be something that you should be looking forward to. Now that we've talked a bunch about GraphQL and what's new with Hasra and all the challenges, let me quickly take you through how Hasra fits in your stack. So as you can see here on the left, that used to be this is the traditional architecture, the MVC architecture, you can call it, where the developers communicate with your monolith, and that in turn returns data to your clients from different services, data sources, databases, etc. And on the right is the Hasra architecture, the Hasra approach of things, where the developer essentially communicates to your Hasra data access layer. Hasra acts as your data access layer. And the interface is going to be GraphQL. So your clients or your developers are going to communicate to your data access layer using GraphQL. And the access layer makes sure that it does all the sanity checks. It's also your authorization layer. It takes care of all the permissioning for you. And it acts as a compiler, as I said earlier, because it also helps with performance a lot, right? Because it's converting these GraphQL queries into SQL statements that in turn gives a JSON response back to your clients or your developers. So it communicates this data unified data access layer communicates to your microservices or serverless business logic, or maybe your databases or SaaS APIs or your microservices, and returns a JSON response back. So that's how Hasura fits into your architecture. Now, the databases that we're supporting are Postgres, SQL Server, MySQL, which is in alpha, BigQuery, which we recently launched, and Oracle and MongoDB are some of the databases that are coming soon. So super excited about that. We'll be adding a bunch of new data sources and databases to our suite of data sources that we support, because the aim is that we support all of the data sources that our developers are using, to make sure that Hasura can continue to be that unified data access layer, and doesn't matter what kind of a data source you're using, you can connect it to Hasura, and Hasura can in turn act as that unified data access layer, and it can give instant GraphQL APIs over your database, so that your clients can communicate to your data sources easily. Now, before we move on to a quick backend demo, I also wanted to talk about how frontend and GraphQL work together. There's also there's a bunch of new client tooling tooling that is emerging, like Apollo, GraphQL, and Oracle. And what these clients do is that these clients, GraphQL has this peculiar specific syntax, right? So these client toolings convert that GraphQL syntax into something that is a more client front-end friendly, right? That's something that your application front-ends can use and consume. It also helps with a bunch of other things, like it helps with caching. Oracle is doing some amazing things around caching and state management. So that's also something that these client tools are solving for. So you don't really have to bother much about how state is handled in your application. You can leave it up to your client tools like Apollo and Oracle to manage it for you, and you can also use GraphQL with it, because GraphQL is supported. There are also a bunch of other things like autocomplete and making your GraphQL queries look prettier. So the entire developer experience is nicer when you're using GraphQL for your front end using these client tools. And there's another entire suite of type-safe GraphQL clients like GraphQL Zeus and a bunch of other really cool type-safe GraphQL clients. And why I wanted to mention this is because even I'm new to the concept of type safety. There's a lot of divide in the community when it comes to type safety, right? Because it's hard to, there's this slight learning curve, but it's becoming slightly easier. I won't say easier, but improved, because these clients are making the entire experience more improved if you're using GraphQL. So GraphQL is strongly typed in nature, right? So if you're using GraphQL, it only makes sense that you also use type-safe clients to go with it, so that you can also create this entire 100% end-to-end type-safe experience for your application consumers and your application users, right? So I wanted to give a shout out to type-safe GraphQL clients, something that I'm also delving into. And quickly going over the challenges of using GraphQL on the front end is, for the front end audience, is error handling, I guess. Apart from state management and caching, which are some of the problems that these client tooling are solving, I think error handling is significantly is something that we need to be talking about, and we need to significantly improve in terms of developer experience and user experience. And what happens in REST APIs is you can manage errors, you can handle errors based off of status codes like 200 or 400, 501, 502, and make sure whether your request was successful or not. And if it wasn't successful, then based on the status code, you can know whether there is an error and what kind of error it is and how to handle it. The thing with GraphQL is that it's always a status, the status code is always 200, right? Because the error code, even if the request wasn't successful, the error code is sent into the JSON body, right? So if you wanted to handle that kind of an error, you would there would be a lot more nuanced mechanism to handling errors in GraphQL, as opposed to how you would handle it in REST based off of just the error codes. In GraphQL, you would want to inspect the JSON body and also get the objects from the error codes that are sent, and then handle the errors in that way by coding, writing code for each error and how you would want to handle it on your front end. So that's about it that I wanted to talk about GraphQL front end and backend and databases. Now let's do a quick backend demo. What I have here is, this is basically cloud.hasura.io. If you go to it, and you can sign up using your Google account or GitHub account. What you can do here is this: you can create a cloud instance of Hasura. So let me go ahead and create a new project here. I will select the free tier. We have a free tier available. I will create a project name. Let's just call it GraphQL Meetup. So if it's available, yes, it is. And when you click create project, it's going to create an instance for you, right? It's initializing here. And when your project is initialized, it's going to create this UI console for you to use, which will be your Hasura project, and you will be able to manage a bunch of things from the UI itself. So let's go, it's initialized. Let's go ahead and launch the console. Might take a few seconds. All right, here we go. So this is how the Hasura console looks. There's a bunch of, if you're new to the Hasura console, you can onboard yourself easily with our tips here. Let's dismiss that for now. Let's look at, if you go to the data tab, let's create a database first. What Hasura lets you do is it lets you connect to your existing database, or it lets you create a free Heroku database. So currently I'm going to create a new Heroku database. So click on create database, and that's it. That's how long it takes to create a database with Heroku in Hasura. And now it's going to connect that database to Hasura. So what happens is you created a free Heroku database, and this is going to be a Postgres database. And yeah, you can see here, it's going to be a Postgres database. And as soon as the database is created, it connects, Hasura connects that database to itself. So what happens is, now Hasura is giving you an instant GraphQL endpoint that you can see here. If you go to the API tab, you get this instant GraphQL endpoint over the database, the Postgres database that you created using Heroku. And I find it really cool. So let's go ahead and view the database so that we can create a few tables. Next. Yeah. Let's create a table that's called users, ID, and then name that is of type text. We can set the primary key as ID and add table. So this is going to create a table in your database. And since the table is created successfully, let's go ahead and add some rows to your table. Let's say wish. Yep. So this is your playground where you can play around with your data in your database using your GraphQL endpoint, right? And this is your Explorer. This is where all of your, yeah, I had that other role set up. Sorry about that. Yeah, so this is the Explorer where, as we all know, GraphQL lets you introspect the entire schema here. So you can play around with the data that is available for you. You can introspect it here. Let's query ID and name. And yeah, it shows us the data in the form of JSON on the right, and that is the data that I have in my table currently. Now let's add. Let's make this a subscription so that we can see how. Sorry, yeah. Let's make this a subscription. Add it, and I'm gonna ask for ID and name and hit play. So it's going to request the data. And while it's still requesting the data from the server, I'm going to go ahead and add another row to my table. Insert another row. Let's say Sam, save it, and let's see if it's instantly available here. It should be. Yep, the data is instantly available here. So yeah, and another thing that I wanted to show here that is really cool is if you go to the table, it lets you set relationships and permissions. So this is going to be your declarative authorization engine. So you can set rules and permissions, access rules and permissions inside Hasura using a declarative configuration like this. So you can create a new role here, set permissions here. For example, let's just create a new role user, select permission with custom check. Custom check could be on ID equals accessory user ID toggle all ID. So we're giving permission for ID and name and save permission. What this is going to do is for the role user, there are two roles, admin and user. And for the role user, we've set a custom select permission. So every user is going to be able to access only their own record. And how this is achieved is there's going to be as you can see, this is something that I hard coded here, but that is the kind of information that is provided in your headers, in your jot tokens, right? And based off of that information, Hasura will decide whether or not you can be able to access the data that you're requesting. So that's about it for Hasura here. There are certain other things that I'll quickly take you all over. The first thing is actions. Actions is another really cool Hasura feature. And what that lets you do is it gives you the power of writing custom business logic. So using actions, you can write a GraphQL wrapper for a REST API. So if you have an existing REST API, you can define a query here, define the types for it here, and connect it to a handler, a webhook handler. And when you do that, what it's going to do is it will convert that REST API into a GraphQL API. The REST API is going to act as a GraphQL API since you wrote a GraphQL wrapper for your REST API. So that's about actions. If you look at remote schemas is a way to bring in your custom GraphQL endpoint. So if you have an existing GraphQL server, your own custom GraphQL server, you can bring it in here by adding a remote schema. So you can give it a name, you can pop in the URL here, and also the header name and header value, and then add remote schema, and it's going to add that remote schema into it. What that is going to do is it will let you inspect the data that comes from that remote GraphQL server in here, so you can possibly query data from both those data sources, your Postgres tables and your remote schema. There's also events. So what event triggers in Hasura lets you do is you can write logic for if someone registers for your newsletter, you can set event triggers so that emails are sent to everyone who registers for your newsletter. So that's something that event triggers do. You can set a trigger name and then schema table, and set a trigger option. Let's say insert. So if there's a new value that is being inserted to your Postgres table, which is the users table. So there's a new user that has subscribed to your newsletter, right? So you can connect it to a webhook URL here, and that is going to create an event trigger for you. And there's also a monitoring tab here in Hasura, and that is something that helps out with performance monitoring and analysis, using regression tests, API limits, rate limits, allow lists, subscription workers, WebSockets, etc. So you can monitor and analyze your operations and GraphQL queries across all your data sources, whether it's a Postgres table, whether it's coming from another database, or if it's coming from your remote GraphQL server. You can analyze the performance of your queries here. So that is something that you can use if you have a production, that depends on what kind of a production ready app you're building with Hasura. So yeah, that's it for the demo. And before wrapping up, I have a bunch of resources to give you folks so that you can, if you're interested in learning about GraphQL, we have a tutorial series which is completely open source. And there are a bunch of tutorials here, which is the Hasura Basics, Hasura Advanced, Auth Patterns with Hasura. And there are also we also have the front-end series. The front-end tutorials are here. This we also have this front-end series. So doesn't matter what kind of a stack you're using on your front end, whether you're a React developer or a Vue developer, or you are a Next.js fan. These tutorials are going to help you get up to speed with GraphQL and set it up for development in your current stack. These are 2-hour quick tutorials that help you build a to-do application using your current stack, your chosen stack, and GraphQL. So check it out and hope that you find them helpful. These are also open source, so you can contribute to them on GitHub. If you also go to hasura.io/docs, this is our documentation. And if you want to learn more about Hasura, then this is going to be the place for you. We spend a lot of time improving our documentation. So hope that is helpful. And if you want to create your first Hasura project, go to cloud.hasura.io. And if you sign in, this is something that you will be seeing. And I already walked you through how to create your first project. So hope you learned something here in my talk today. What I was aiming to do was speak to various kinds of developers, be it front-end developers or back-end developers, people who are interested in learning about GraphQL, and trying to show how Hasura is solving the problem of a lot of things about app development using GraphQL. So hope you liked my talk and found it helpful. Thank you so much. That's all from my side.
Thank you so much.
Yeah, thank you so much. That's like a really nice talk, and I think to be honest, I have seen Hasura a lot, but I have never used Hasura in my side project. So I think this is going to make me like want to use Hasura in my next side project. So that's very nice talk. Thank you.
Thank you so much.
Thank you for joining us. And will you join our open session?
Yeah.
Okay, then if anyone wants to talk with you more, please go and follow us on the Get a Town on open session, and you will be there. We will be there to talk with anyone want to talk more about Hasura or anything, right?
Yeah, sure.
Okay. Thank you so much for today. It's a great talk.
Thank you so
Thank
much.
you so much.
Thank you so much. Goodbye. See you.
So yeah, that's like a really nice talk from the Hasura side. Yeah, I really enjoyed that a lot. But to recap what the talk is about, so let's recap what talk is about. So to recap, Hasura helps developers and operation teams to use GraphQL without worrying about concerns such as a single point of failure and performance. Hasura acts as a unified data across layers, so you are able to get the data from the across multiple databases. So yep, that's like a quick recap from what talk is about. And
And you can.
we also have like a Thai version of the recap.
Yes, of course. For Thai version Hasla นะคะ Hasla จะช่วยให้เรานะคะสามารถเข้าถึงข้อมูลจากหลายๆฐานข้อมูลพร้อมกันนะคะแล้วก็ยังช่วยให้นักพัฒนาแล้วก็ทีม DevOps นะคะใช้ GraphQL ได้โดยที่ไม่ต้องกังวลปัญหาของ Single Point of Failure นะคะก็คือsorry ค่ะเป็นความล้มเหลวที่เกิดจากจุดเดียวนั่นเองนะคะแล้วก็จะช่วยเรื่องของประสิทธิภาพของระบบด้วยค่ะก็ถ้าเกิดว่าใครสนใจ Hasura นะคะก็ลิงก์เมื่อกี้เนาะเป็น hasura.com/doc หรือว่า /learn นะคะก็เข้าไปดูกันได้ค่ะแล้วก็สุดท้ายนะคะอย่าลืมฟีดแบ็กให้พวกเรานะคะเดี๋ยวจะขึ้นเป็น QR code สำหรับฟีดแบ็กนะคะแล้วก็เป็น QR code สำหรับไปจอยกันใน Open Session นะคะที่ Garten นะคะค่ะออม
Yeah, we hope to see you in Garten on the open session in Garten. And if you have any feedback, you can use the QR code on the screen to comment and show what you think about this meetup, so we can improve on the next talk. Yep.
Yeah, so we already comment on the Facebook and on the YouTube live. So please join us in Go session and see you there. Thank you everyone for joining us. Thank you Kun Om for being moderator with me. And thank you all speakers that show up today. Have a good night and have a good open section in the next. Don't forget to join us.
I'm feeling so hollow. Don't you know? Don't you know? I'm living in shadow. Don't you know? Don't you know? I fell for fool's gold. I fell for fool's gold. What did I know?